everyone. I am Ronnie Carlos Jr. The problem solving and reasoning. Reasoning. Mathematics is not just about the numbers. Much of it is a problem solving and reasoning. Problem solving and reasoning are basically inseparable. The art of reasoning is very important in mathematics. This is the skills needed in exemplifying the critical thinking and problem solving ability. Intuition is similar to guessing. It is also called the reasoning by guessing or reasoning by common sense. Requires less mental activity, and intuition is ability to acquire knowledge without the proof, evidence, or conscious reasoning, or without understanding how the knowledge was acquired.
Example, look at figure A and B, which is bigger. You can give your answer by using intuition without actually measuring.
Analogy is a form of reasoning in which other similarities are inferred from a particular similarity between two or things. It is a reasoning by comparison. Example, tree is the leaf as flower is the fatal. Hammer, nail, comb, air. Finding a good man is like finding a needle in a haystack.
Problem solving, inductive and deductive reasoning. So in mathematical reasoning, on the other hand, it helps individual build mathematical critical thinking and logical reasoning. A lack of mathematical reasoning skills may reflect not just in mathematics performance, but also in physics, chemistry, or economics. Inductive reasoning, it refers to the process of making generalized decisions after observing and or witnessing repeated specific instances of something. So inductive reasoning is a logical guess which can be backed up by using valid reason. When we say inductive, it goes from specific to general. For example, premises 1, Simon is a grandfather. Premises 2, Simon is bald. So in conclusion, all grandfathers are bald. So as you can notice from the specific observations, all grandfathers are bald just because of those two observations on premises. So always remember, inductive from specific to general. Deductive reasoning, it refers to the process of taking the information gathered from the general observations and making specific observation based on that information. So therefore, deductive reasoning is used for geometrical and mathematical proofs. So take note that in deductive reasoning, we go from general to specific. Example, premise 1, all humans are kind. Premise 2, Sandro is human. In conclusion, Sandro is kind. So as you can see from the general observation that all humans are kind, we arrive at a specific conclusion that Sandro is kind. Euclid, also known as Euclid of Alexandria. So he was a Greek mathematician, often referred to as the founder of geometry or the father of geometry. So his Elements is one of the most influential works in the history of mathematics, serving as the main textbook for teaching mathematics, especially in geometry, from the time of its publication until in the late 19th or early 20th century. So he initiated a new way of thinking. The study of geometry introduced the method of proving a geometrical result by deductive reasoning.
Today we will talk about if-then statements and converse. Conditional statement consists of hypothesis and conclusion. We always remember that the first statement is P is called hypothesis and usually begins with F, while the second statement is Q, which is usually begin with then is called the conclusion. If hypothesis, then conclusion. So here's the example, identifying hypothesis and conclusion. So number 1, if a number is greater than 0, then the number is positive. So the hypothesis, which is P, that always after the F word, and since we have then, so we can easily to identify Q, which is our conclusion. The hypothesis statement is a number is greater than 0, and the conclusion is the number is positive. Next, the converse of an if-then statement, when the hypothesis and the conclusion of an if-then statement are interchanged, the new statement is called the converse of the original if-then statement. If is P, then is Q. Converse, if is Q, then is P, so there's having interchange. Here's the example statement. If it is raining, then it is cloudy. And the converse is, if it is cloudy, then it is raining. And converse of true statement can be true or false. For example, it is true that it's raining, then it is cloudy, because rain came from cloudy, so that's true. While the converse is false, because if it is cloudy, then it's raining. There is no possibly overcast but not raining. Next is if and only if statement or biconditional statement. If a statement is true and the converse is true, we can make the statement P if only if Q. Consider this true conditional statement. Write its converse. If the converse is also true, combine the statements as a biconditional. And conditional, if the battery-powered calculator runs, then the batteries are good. So that's the example of conditional. And to take into interchange, which is converse, if the batteries are good, then the battery power calculator runs. And the last is we're going into biconditional statement. The battery-powered calculator runs if and only if the batteries are good.
Talking about mathematical proofs. Mathematical proof is an inferential argument for a mathematical statement that demonstrates that the stated assumption logically ensure the conclusion. So there are three types of common mathematical proofs. So the first one is proof of contradiction. It's a type of proof in logic and mathematics that establishes the truth or validity of the proposition by demonstrating that assuming the proposition to be false leads to contradiction. Second is proof by induction. A proof by induction is similar to a regular proof in that each step must be justified. So the last one is direct proof. Direct proof is a method of demonstrating the truth or falsity of a given statement in mathematics and logic by using a simple combination of established facts, usual actions, existing lemmas, and theorems without making any additional assumption. So next is algebraic and geometric proofs. An algebraic proof shows the logical arguments behind an algebraic solution. Geometric proofs are given statements that prove a mathematical concept is true. So there are 5 important properties of algebra: reflexive, symmetric, transitive, substitution, and distributive. So the next is commutative properties. Is a binary operation is said to be commutative. It's changing the order of the occurrence has no effect on the result. So the next is associative properties. The associative properties is a property of some binary operations in mathematics, which means that rearranging the parentheses in an expression has no effect on the result.
Geometric properties. So what is geometric properties? When we say geometric properties are those that can be derived from the geometry of a solid body or particle. They are very important as a means by which the size and shape of an irregular shaped particle can be easily quantified. Reflexive property. In algebra, the reflexive property of equality states that a number is always equal to itself. Reflexive property of equality: if A is a number, then A equals A when A equals A. The symmetric property. The symmetric property of equality tells us that both sides of an equal sign are equal no matter which side of the equal sign they are on. Remember, it states that if x equals y, then y equals x. Transitive property. When we say transitive property states that two quantities equal to a third quantity are equal to each other. Next, addition property of equality. If two expressions are equal to each other and you add the same value to both sides of the equation, the equation will remain equal. Next, the congruent segments. When we say congruent segments are segments that have the same length. Next, definition of equiness, the equality or state of being between two others in an ordered mathematical set. Next, definition of midpoint. A midpoint are a point that divides a segment into two congruent segments.
How to write proof. So there are two kinds of proof that commonly used in proving theorems. So when we say theorems, let's use direct proof and indirect proof. So in direct proof, one assumes that premises are true and deduces conclusion from the example. Prove that any two right angles are congruent. State the statement using if, then form. So if angle A and angle B are right angles, then angle A is congruent to angle B, then visualize what is to be proven by drawing the necessary figure or figures. Assume the hypothesis. List the given statement. Angle A and angle B are right angles. Next, establish the truth of the conclusion, then prove. Next, we have here the proof. So we have the table here for statement and reason. So now we will go to indirect proof. So indirect proof usually is a paragraph form. The opposite of the statement to be proven is assumed true until the assumption leads to conjecture. Example: if n is even, then by the definition of even number is n equals to 2a, where is any integer. So n squared equals to 2a squared, then equals to 4a. This means that n squared is multiple of 4. No odd number can be divided evenly by an even number. Therefore, n must be odd if n squared is odd. I hope you learned. That's all for today. Thank you and God bless.